Somewhere out there, 24 billion kilometers from where you're sitting right now, a spacecraft the size of a small car is drifting through complete and total darkness. It has no camera pointing forward, no crew, no way to call for help. It runs on less power than the light bulb in your refrigerator. And in early 2026, it sent something back. Not the usual data, not the routine readings NASA engineers had grown used to monitoring. Something different. Something that made the scientists at the Jet Propulsion Laboratory stop what they were doing and stare at their screens. For 72 hours, nobody had an explanation. This is not a theory. This is not speculation pulled from a fringe website. This is what actually happened, and what they eventually discovered challenges everything we thought we understood about the boundary between our solar system and the infinite void beyond it. Stay with me, because this story gets stranger the deeper you go.
To understand why this signal matters, you first need to understand what Voyager 1 actually is. Because most people hear NASA spacecraft and imagine something sleek, something modern, something built with the kind of technology you'd expect from the most advanced space agency on Earth. Voyager 1 is not that. It was built in the 1970s, launched on September 5, 1977, nearly 50 years ago. The computer on board has roughly 70,000 times less memory than the phone in your pocket. Its original mission was designed to last 4 years. 4 years, that was the plan. Instead, it is still alive, still transmitting, still teaching us things in 2026. The only reason it has any power at all is because of a small nuclear battery, a radioisotope thermoelectric generator that has been slowly decaying for half a century. Every single year, it loses about 4 watts of power. Engineers have had to make brutal decisions, shutting down instruments one by one, choosing which eyes and ears to keep open and which ones to turn off forever, just to keep the most important systems running. Think about that for a moment. Voyager 1 is essentially a 1970s computer running on barely enough power to light a dim bulb, whispering signals home across 24 billion kilometers of nothing. And it is still talking. That alone is one of the greatest achievements in human history. But what it has been saying lately is what brings us here today. How we even receive these signals. Before we get to the anomaly, there's one more thing you need to picture clearly, because it makes what happened even more remarkable. NASA receives Voyager's transmissions through something called the Deep Space Network, 3 massive antenna complexes positioned around the globe in California, Spain, and Australia, so that as the Earth rotates, at least one dish is always pointed toward Voyager's location in the sky. These dishes are enormous. Some span 70 meters across, and they need to be because the signal arriving from Voyager 1 is almost unimaginably weak. By the time Voyager's transmission reaches Earth, it carries 20 billion times less power than a single-use watch battery. And even traveling at the speed of light, that signal takes over 22 hours to reach us. 22 hours, one way. So if NASA sends a command to Voyager today, they won't know if it worked for nearly 2 days. The data rate itself, the speed at which information comes through, is 160 bits per second. That is slower than the internet connections people used in the 1980s. Every single bit of data from Voyager is precious, fought for, earned, pulled across the largest distance any human object has ever traveled. So when something unexpected comes through, when the data doesn't match what it should, you don't dismiss it. You stop everything and figure out what it means. Which is exactly what happened.
The anomaly. It started with Voyager's attitude control system. This is the system that keeps the spacecraft pointed in the right direction, making sure its antenna is aimed at Earth with enough precision to send those faint signals home. It does this by firing tiny thrusters, making micro-adjustments, keeping the probe stable. In early 2026, engineers noticed something strange in the attitude control data. Voyager appeared to be responding to something external, a subtle force or a change in the environment around it that was causing unexpected rotation readings. Now, this had happened once before, back in 2023. At the time, engineers attributed it to the natural degradation of aging hardware and moved on. But this time, the readings were stronger, and they repeated. More importantly, the pattern was too structured to be random decay. Random hardware failure produces noise, chaos. What engineers were seeing in the 2026 data had a rhythm to it, a repetition. Something out there was pushing back. To understand what might be causing this, we need to talk about where Voyager actually is. Because most people imagine deep space as empty, a perfect vacuum, nothing but the occasional distant star. That is not what's out there. Beyond the heliopause, the official boundary where our sun's influence ends and true interstellar space begins, the environment is alive with invisible forces. Interstellar plasma, magnetic fields twisted by thousands of years of stellar winds, cosmic ray particles launched by supernovae that exploded millions of years ago, still racing through the galaxy at nearly the speed of light. Voyager 1 crossed the heliopause in 2012. It became the first human-made object to enter true interstellar space. And in the years since, it has been our only live instrument in that alien environment, our only set of eyes and ears beyond the solar system. What it found immediately surprised scientists. The interstellar medium, the technical term for this space between stars, was denser than our models predicted, more turbulent, more structured. And the new 2026 signal suggests Voyager may have now entered a previously uncharted density layer that nobody knew existed. The signal nobody expected. Here is where it gets truly extraordinary. Among all the data Voyager's remaining instruments collect, one of the most valuable comes from its plasma wave science instrument. This instrument detects oscillations, vibrations in the plasma of interstellar space, the way a microphone picks up sound in air. In 2026, that instrument recorded a repeated, structured fluctuation unlike anything in Voyager's 49-year history of data. It was not coming from the sun. It was not matching any known human-made interference, and it was arriving from outside the spacecraft's expected signal environment entirely. Scientists immediately began working through explanations. The leading theory right now is that what Voyager detected is a shock wave, a pressure wave rippling through interstellar plasma triggered by a massive stellar event somewhere in the galaxy, possibly a distant supernova, a star that died in an explosion so powerful that its shock wave has been traveling through space ever since, finally washing over Voyager like a wave reaching a shore after crossing an ocean. But there is a second theory, and this one is the one that made astronomers sit up straight. The density structure Voyager is now detecting could represent the inner wall of the local interstellar cloud, a vast cloud of gas and dust that our entire solar system has been drifting through for tens of thousands of years, and we may be approaching its edge. In other words, Voyager may be showing us the exit door of the cloud our solar system calls home. Every generation has a moment when the universe reminds them of two things simultaneously: how small we are and how extraordinary it is that we exist at all. The Apollo missions did it in 1969. The Hubble Deep Field Photograph did it in 1995, when we pointed a telescope at a patch of sky the size of a grain of sand and found 3,000 galaxies hiding in the dark. The James Webb Space Telescope did it in 2022, showing us stars forming 13 billion years ago. And Voyager's signal in 2026 is this generation's moment. Think about what we actually did here. In 1977, a team of engineers working with slide rules and early computers, without GPS, without the internet, without any of the tools we take for granted, launched a spacecraft so precisely that nearly 50 years later, it is not only still functioning, but it is teaching us things we didn't know last year. That is not just science. That is the most human story ever told. NASA's Deep Space Network will keep listening, every day, pointed toward a dot in the sky that represents the furthest reach of human ambition, waiting for the next transmission. Scientists are currently analyzing the full scope of the 2026 plasma wave data, using artificial intelligence models that didn't even exist when Voyager was launched. A peer-reviewed paper on the anomaly is expected to be published later this year, and when it is, it will almost certainly reshape our understanding of the space between the stars. And when that paper drops, I'll be here, breaking it down, frame by frame. So if you want to be here for that, subscribe, hit the bell, because this story is far from over. Before you go, I want to leave you with one thought. Voyager is carrying the golden record, a message from humanity to anyone who might find it billions of years from now. It was loaded with sounds and images that Carl Sagan and his team believed best represented who we are. But that record was made in 1977. So here is my question for you, and I genuinely want to know your answer. If you could add one thing to the golden record, one sound, one image, one idea that represents humanity in 2026, what would it be? Drop it in the comments. I read every single one, and the best answers might just make it into the next video. Thanks for watching, and thank you, Voyager, for not giving up.